The reason is understandable, no? Because there are too many reasons. Reason number one, tropical storm. Reason number two, holiday. Reason number three, the topic is hard. The topic is abstract. This is no like intermediate algebra, que is basically the manipulation. So we have some concept, weird concept behind the idea. Yeah, I know that the students don't understand very well. This is traditional. Test number two in college algebra, a lot of people fail. So I call in funny way que I need to call 911. So this is classic. This is no surprise for me. However, I make a decision to give the another opportunity. Okay, to say I control, no? I control Alex. I get inside Alex. I change the due date for the test two. So the due date of test number two online, I change. I change to next Monday, so November 23rd. November 23rd. So you can, entonces I modify the amount of attendance. So we have one more attendance. Okay, one more. So you can repeat again one more time. Okay. Another thing. The student can want stay after the class. I bring 1, 2, 3, 4, 5 example can cover the most complicated part of the test. Okay, I can solve it here, but using because I open Alex the test too, but I see my platform and not necessarily it's exactly the same your problem, no? But it's the same concept, the same topic, the same idea. Because I want to explain. If you want, no mandatory guy, that when the class is over, we have very, very busy day today. You stay here, maybe, I don't know, 15 minutes more. And I prepare for you some problem. By the way, some student, dedicated student, ask for help. So send me email, professor, solve for me this. So in this moment, I send the answer, right? But okay. Anyway, remember you can count on my help anytime. So you email me, ask me for a specific, but you need to learn, coño. Si you don't learn, you don't pass. It's obvious, right? Okay, any question? Do you understand the idea? So extending, actually I did that. So when you open this test two and homework, the homework corresponding with the test two is extended to November 23rd, que es the next Tuesday. Entonces, well, okay, entonces in this time, remember this is too intensive course and you have to working in this plus the test number 3 que we are doing now. Any question? Clear? Happy? Chance? Take advantage.
Yes.
Take advantage. And Ernest, take advantage. I know that you are good students. So you need to dedicate more time with me. No, my pleasure. This is my job. Okay,
Thank you.
I always help my student. Always help my student. Okay, guys, let's continue with the topic today. Okay, remember was about. Let me record. It's recording now. Okay, super. It was about the rational function. I suppose you remember rational function. Rational function. Rational function is, by definition, okay, is, wait a second. Okay. Okay, good. It's the division to polynomial. The function f of x like that is p of x divided by q of x. It's a rational function when the supposition is p of x and q of x both are polynomial function. Polynomial function. Okay? Ajá. Okay, entonces in this moment, so we finish the last lecture with the idea for the vertical asymptote. Vertical asymptote. Vertical asymptote is a line que is no part of the curve, but it's auxiliary construction que help me to understand the graph of any rational function. So what is the definition? What is the definition? Definition of vertical asymptote. Well, it's a number in which when you approach it, so this arrow indicates not equal, so you approach it. You approach it to the number c, the function approach it to infinity. Infinity is, remember, a symbolic way to indicate it's a huge number. Maybe positive infinity or maybe negative infinity. Let's see, let me try to understand the idea geometrically of the vertical asymptote. Suppose we have 4 options, 1, 2, 3, and 4 options of the vertical asymptote. Suppose the x-axis, xy axis, x, y, x, y, x, y, x, y. Suppose we have that situation. Look, no, here. We have here, and the point C, so C is the x value, and the point C, and the point C, and the point C, we have this behavior. Look, I did that. I did that, Miriam. Let me check in just in case, Miriam. Yeah, I did that. Okay, actually, we are recording now. Okay, thank you. So we have this behavior. Look at that. Look at that. Look at that. Look at that. We have this behavior. Maybe the curve. Okay. Now I put in blue color. Approach it, but never touch. So maybe you have this behavior. It's possible to see that, or this behavior. And the part to the right is positive, or this behavior. The part to the left is negative, and the part to the right is positive. Or both negative. So how do you know this? Si es behavior 1, 2, 3, and 4. Easy. Because you evaluate, suppose you determine C, que es the asymptote. I want to explain how you determine. And you evaluate a little bit before and after. When you evaluate before, see the answer is positive. When you evaluate after the C, the answer is negative. The behavior look like that. See, both are positive. It's like that. See, this is negative, a noise, and this is positive. It's like that. Are negative. It's like, oh, what the hell? Noise. Active, no. Okay. So how you determine C? Well, C is easy. C is when you have, for example, the rational function. You remember P of x divided by Q of x. After the simplification, you factor out and cancel out the common factor. Okay, you take the polynomial at the bottom and you enforce it to be 0. And division by 0 is undefined. And undefined is similar to infinity. So you solve this equation and you find the C value that corresponds with the vertical asymptote. Let's see a couple of the examples to illustrate very well this idea. And let's see the graph in Desmos. Okay, identify how you identify vertical asymptote in the rational function. Okay, how you identification. Okay, identify file vertical asymptote. Okay. Okay, basically, remember, you take the polynomial at the bottom equal to 0. This is the key idea. Example 1 to understand this. Well, in the example 1, f of x is a rational function, is 2 over x minus 3. Okay? Okay? And you say, well, professor, weird. No, it's not weird. 2 is polynomial degree 0 because we have no x. And x minus 3 is polynomial degree 1, no? Because the exponent, remember the degree is the higher exponent of the x variable. Okay, this is a rational function. However, in order to identify the vertical asymptote, you take the polynomial in the bottom, gets x minus 3, and you enforce it to be 0, and the solution is 3. And then I suppose that at x equals 3, we have vertical asymptote. Now, what behavior? Well, the behavior is easy because you evaluate a little bit after before and after. So suppose in my all real number line, I suppose in 3, we have a vertical asymptote. And you evaluate maybe in 2, in 4. Where are the function? The function evaluated in 2 is 2 over 2 minus 3. So you replace using function notation, no? X for 2, this is 2 over negative 1 is negative 2. So this is negative 2 here. Suppose this is the y-axis. This is the x-axis, negative 2. I suppose negative 1, negative 2 here. And 4 is 2 over 4 minus 3. Entonces 2 over 1 es positive 2. Entonces es positive 2, que es 1, 2 here. Entonces I suppose, roughly sketch, no super detail, que my curve look like that. And this is asymptotically. When it's asymptotically, the curve approaches to the asymptote, but never touch. Okay? And the other part look like that. Just in case, to see more elegant, we use decimals, of course. Always we use decimals. Okay? Let me switch into decimal to see this example in detail. Okay, decimals. Okay, switch into decimals. Cool. Okay, decimal now. Okay, look at that. Example 1 for today is something like that. Okay, this is the graph. Let me make a zoom. And 3, x equals 3, we have vertical asymptote. So the vertical asymptote always, by convention, we are using black color. Look, black color, dotted line. Look, black color, dotted line. And the curve you select the color that you prefer. Blue, red. So remember, you click here, hold the mouse, and you select the color. Suppose you prefer red color. Okay, red color. It's good. Okay. Any question, guy? Vertical asymptote. Okay, this is my first example, no? I promise we see several examples of vertical asymptote. Okay. Now, let's move on again to the board. Let's analyze example 2 now. Do you see the whiteboard or no? Yes or no?
No.
Not yet.
No, not yet. Okay. Okay, no problem. Now?
Yes.
Okay, super.
Yes.
Let me erase the whiteboard. And let's discuss it now. Example 2. Look at that. Example 2 is a little bit more interesting. Because in example 2, you have the function g, and the function g is x minus 3 divided by x squared minus 5x plus 6. We have two polynomials, no? The polynomial at the top, degree 1. The polynomial at the bottom, degree 2. Because the exponent is 2, the higher exponent is 2. Okay? So now, what should I do? Always, step 1, step 0, to start factorization, factor 4. I copy x minus 3 divided by, and you factorization the trinomial. X, and the combination in that case is 3 and 2. Because 3 times 2 is 6. Somehow 3 plus 2 is 5, and both negative. I suppose that the student understand very well this, no? Yeah, this is classical in factorization. Now you can see, wow, look at that. The factor x minus 3 is canceled. And only stay alive in the top, nothing. In the bottom, x minus 2. Then the factor gets canceled out. The factor gets gone. It's a whole. And the factor that stay alive in the denominator part is the vertical asymptote. So you take x minus 2 equal to 0. X equal to, this is my vertical asymptote at x equal to. And you evaluate a little bit before and after, maybe in my whole real number line. Okay, 1, 2, I know again 2 we have vertical asymptote. And you evaluate in 1. In 3, no, because in 3 we have a hole. At x equal 3, we have a hole. So I suppose that when you evaluate in 3, it's undefined also, right? You evaluate in 4. So you evaluate where? You evaluate, well, in the original equation, yes, you can. But in this simplified, it's much better and more elegant. So you evaluate, for example, in 1, so say 1 over 1 minus 2 is 1 over negative 1 is negative 1. So f or g evaluate in negative 1 is negative 1. It's in 1, sorry, is negative 1. The 1, negative 1, I suppose to here. Negative 1 point here. And in 3, remember, no, it's impossible because in 3 we have a hole. You see what is the representation for the hole. Well, let's do it now. And evaluating 4, g in 4 is 1 over 4 minus 2. 4 minus 2 is 2, is 1 half. So 4 is 1 half. See, this is guy is 1. 1 half is the half of this segment. Okay, so I suppose that the representation is like that. So the graph look like that. This is roughly. This is no exact answer, right? And this is in that direction, it's like that. But be careful because in 3 we have a hole, and the representation for the hole is something like that. It's like an empty circle. Wait. It's a hole. It's a hole. Let me use a hole like that. In 3 we have a hole, and the rest is okay. So the difference between look, it's important. Okay, basically, if you analyze the domain for the original equation, domain is all real number. Domain is all real number. Is all real number except the restrictions, and we have 2 restrictions because we have two factors in the denominator. The bad guy is x not 3 and x not 2. But it's important notice in 3 is a whole because it's a factor gets canceled out after the simplification, and 2 is a vertical asymptote. So what is the conclusion? What is the conclusion? If you want to find the vertical asymptote, always you are doing the factorization, the polynomial at the top, the polynomial at the bottom. You simplification the factor que is common if exists. Otherwise, no. The most common case, no, happen that situation. But you cancel out. And the factor gets canceled is a whole. And the factor que stay alive in the bottom is the vertical asymptote. Okay? Let's move on to Desmos to see this idea. Desmos now. Desmos now. Switching to Desmos. Switching to Desmos. Okay. Do you see Desmos or no? Okay, let's move on to example 2. Do you see or no?
Yes, we do.
Look at that, look at that. And the equation is g of x is equal to x minus 3 over x squared minus 5x plus 6. We have one vertical asymptote at x equal to, and we have the famous hole in 3,1. So look, we have different style to represent the point. You have the classical point, you have the hole, like that, and you have the cross. I don't know why you're using the cross, but in mathematics, you're using a hole or no hole, or just a point. Any question? Any question about the vertical asymptote? Okay, guys, I try to explain now, right now, in this moment, the theoretical part. I promise in few minutes, we go over the entire example. So the first theoretical part that we discussing is vertical asymptote. Now I want to discuss it now, horizontal asymptote. Horizontal asymptote. What is horizontal asymptote? Horizontal asymptote. Okay, now horizontal asymptote. Look. Horizontal asymptote definition. Horizontal asymptote. Okay, what is that? Bueno, es like an behavior of the function. What means end behavior? End behavior means that when the x approaches to positive infinity or negative infinity, in both directions, a huge number, the function approaches to a specific value that we want to call d. So let me interpret this idea geometrically. Look, we have three typical situations. Remember, this is x-axis. And that direction is positive infinity. And that direction is negative infinity, no? Those are now, suppose the vertical, the horizontal, sorry, asymptote is a horizontal line. And the equation for any horizontal line is y equal d. In this case, d, I call d the value. Suppose d, this value. Bum, 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 bum. Bum, 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 bum. This is the horizontal line. Always the asymptote, you using black color and dotted line. Now, suppose the curve, there are several examples. Suppose the curve like that. Approach it, but never touch. Okay? Another possibility is like that. But in this case, we have both. We have a horizontal and we have one vertical here. Okay. And the another possibility, not too common, seldom happen, is that the curve touch the asymptote in one specific point, and this point is important to determine. Okay, this is the picture of the possibility, no, of the horizontal asymptote. Entonces, how do you know, how you determine the position, the location of the horizontal asymptote? Well, this is complicated, but I try to explain. Suppose this example. Example 1, no, of the horizontal. Suppose the function g is equal 7x squared plus 2x divided by 4x squared minus 3. This is typical rational. We have division to polynomial. The degree of the polynomial in the top is 2, que es the highest point. The degree of the polynomial at the bottom is the same. Okay. Therefore, when this situation happens, when the degree, so if degree of P, okay, P I call the polynomial at the top, is equal degree of Q, que es the polynomial at the bottom. When this situation happens, in this case happen, of course, the conclusion is then we have horizontal asymptote. At, and it's the most important moment. Yes, we have. Yes or no? Yes, we have. But at what value? At y equals 7/4. And where come from that number? 7 is this 7. Look, this 7 is this 7. And 4 is this number. Okay, basically, you divide the leading coefficient, that the coefficient in front, the expression who the degree is 2 in this case, well, the higher degree, huh? The higher exponent. You take higher exponent divided by higher exponent. Do you understand this idea or no? Confusing? I explain well or no good?
You explain well, but
Uh-huh.
can you explain a little bit over, please?
Of course. Okay.
All right,
Okay.
thank you.
This is the base idea. Entonces, I bring 2 examples, and you help me to understand. Okay, the answer I need is example 2, example 3, and you help me to discover what happened in the example 3. Example 2, and 3. In the example 2, we have this function h of x is equal 8 x to the second power plus 9 x minus 5 divided by 2x squared plus 1. And the second is p of x is equal x squared plus 7, 11 minus x squared. Okay? Entonces, in both examples, I want to determine if we have or no horizontal asymptote, and at what value is located the horizontal asymptote. And remember, the analysis is always the same. And the analysis is the degree analysis. You see, wow. Degree of the polynomial at the top in the second example is 2. Degree of the polynomial at the bottom is 2 again. So the answer is yes, we have, because degree is the same. But at what value? Y equals something. Y equal what? Tell me.
Equal 8/2.
A over 2, and A over 2 is 4. Okay? So when I do the graph of this function, in one moment, I need to put in 1, 2, 3, and 4, one horizontal line. I don't know exactly what happened here, but the graph look like that. Okay, approach it to positive infinity or negative infinity, or both, maybe like that. This is important. What do you think about the example 3? In the example 3, we have or we have no horizontal asymptote. Remember, the analysis of the degree. What is the degree of the polynomial at the top? Tell me.
1.
No, 2. Natalie Navarro say 2. Why 2? Look at that, this 2. The higher is...
Yeah.
And what is the degree of the polynomial in the bottom?
2.
2 again, because this funny. I put to confuse you in different order, but you are clear. No. I don't care the order. The order is not important. What is the higher important? 2. So is, remember the definition. We have horizontal asymptote when the degree is the same. But at what value? At y equal? Boom.
Is it -1?
-1. Very well. It's a -1. Where come from this -1? This leading coefficient is a +1. This leading coefficient is -1. So +1 divided by -1 is -1. Very well, miss. Very well. Do you understand very well? the horizontal, the analysis of the horizontal. Let me complete. Wait. Unfortunately, you understand. Okay, Natalie. By the way, Natalie is excellent student. Natalie have 100 points in every test, online and on paper. Okay. Let me bring another special case. This is a regular case. This is the most frequently case we can see when the degree is the same. But we have another case in which we have also horizontal asymptote. Suppose the example 4. In the example 4, we have h of x is equal 5 over 4x squared plus 9. Entonces we have two polynomials. Well, in this case, polynomial is a constant, no? Degree 0. And in this case, it's also polynomial degree 2. Entonces this is a special case. A special case is when the degree, if the degree of the polynomial in the bottom, que always I call Q, is greater than the degree of the polynomial in the top, I call always P. The conclusion is then we have also horizontal, pero es especial. Es always at y equals 0. Okay, so we have, see, I try to summarize the idea. This is complicated. Let's do it little by little. I suppose that today we have time to cover every possibility and a lot of examples. And also, guys, when you are doing the homework online, and Alex, any question that you have, please send me by mail. You take a picture and send me. I try to solve it as soon as possible. I send the solution. This is a process online. Unfortunately, you don't see my face physically, okay? However, the student learn in that way and learn very well because in another class, the students are doing very well. There are no reason to fail. Yeah, I know we have potential. I have excellent students here because I take with me this semester, but in the first part of the mini term. I have excellent students, like a Chance, like a Ernest, super, like a Covarrubias, excellent student. And continue. Why not? I know it's hard. College algebra is a little bit hard. Okay, it's not my fault, no? Okay, so we have horizontal in two cases. When the degree is the same, or when the degree of the polynomial in the bottom is greater than. Suppose another example. Example 4, 5, and 6. Let me create two examples. 5 and example 6. And you let me know. Suppose the function m is equal x plus 3 divided by 3x to the 4th power plus 5. And we have another polynomial that I call g. Is x squared minus 5x plus 6 divided by x cubed plus 3x squared plus 2x plus 5. Two rational functions. And the question say, analyze if it's possible or no, or we have or no horizontal asymptote. This is the idea. Then you analyze, wow. The polynomial at the top here, degree is 1. The polynomial at the bottom, degree is 4. Oh, when this situation happens, when the degree of the polynomial at the bottom is greater than, yes, we have. It's special, but we have. Yes, we have horizontal asymptote at y equals 0. In the example 6, the degree is 2, degree is 3. Oh, again, it's greater than degree of the bottom. Therefore, we have. Yes, we have the same reason. So this answer is valid also for this example. The idea behind this is clear. Okay, when the degree of the polynomial is bigger, it's because this polynomial increasing faster than this polynomial, no? And see in one expression, the expression increasing faster. Suppose this elementary example. Suppose reciprocal function. Suppose example 7. Suppose the example 7 is the function f of x equal 1 over x. Okay, it's a reciprocal function. Wow, it's easy. Now degree of 0 because we have no x, and degree of 1. So I suppose, yes, we have at y0. It's special. But let me try to understand. Remember the horizontal asymptote represent like end behavior. And what mean end behavior? I suppose I want to simulate x approaching to infinity. Infinity positive or infinity negative, doesn't matter. Infinity positive is much better to see. Suppose this statement indicate x increasing forever. Suppose 10, 100, 1,000, 10,000, 100,000, 1 million, okay? So you divide 1 over 10, you put in the calculator 0.1. 1 over 100 is 0.01. And 1,000, 1 over 1,000 is 0.001. And 10,000 is 0.0001. And so you continue increasing the bottom part faster than, in this case, the top part not increasing, it's constant. You see that the answer approaches to 0. Approach it to 0. Approach it to 0 because it's smaller, 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 never negative, never negative. Typical behavior like that. So we have here like a horizontal. A little bit clear now? A little bit, not too much, but a little bit, right? Okay, let's move on to example 8. And the example 8, we're discussing another new topic. New topic, no, the same idea, but I want to discuss in the particular cases in which the curve, the function, crossed the horizontal, because sometimes happens. So I want to investigate that situation now. Look, in the example, the last box we covered was A, no? It's A, yeah. Okay, thank you. Okay, in the example 8, I want to investigate, look, this behavior. Suppose, yes, we determine very well that we have horizontals. But sometimes happen that my curve cross it. Here, no. 1 point, specific 1 point, in which the function is represented by the blue curve, this is the function, cross the horizontals. Okay? Let's see the example A, because example A is a function I call h of x. And h of x is ax squared plus 9x minus 5 divided by 2x squared plus 1. Okay. So the investigation that we are doing now is determine, professor, si we have or no horizontal asymptote, at what value is the horizontal asymptote, and also the new one that we investigate is a cross or no the horizontals. Okay, the answer is obvious. Yes, we have. We have because degree of the polynomial at the top is 2, degree of the polynomial at the bottom is 2, and when the degree is the same, that means that this polynomial increasing in the same speed, in the same rate of change. So this increasing fast, but this increasing at the same speed. And when the situation happens, we have in the infinity, and the end behavior is a divided by 2 is 4. Okay, no problem, all right? So we determine, yes, we have. Yes, we have. And also at y equal 4. This is no new. You know that. I don't know. The new thing is determine si cross or not. To determine si cross or not, you copy our function again. And you now enforcing to be equal to the square plus 1. You enforce it to be equal 4. Because in this case, the horizontal asymptote is y equal 4. Let's see, exist or not. Sometimes happen that when you solve in this equation, we found the solution, okay? And sometimes happen that when you try to find this equation have no solution. This is a situation happening in algebra, you know. And see, no solution is because this point that I try to find do not exist. See, we have solution, of course, yes, exist. Okay, for solving this equation, it's easy. You apply cross multiplication. You multiply this polynomial times 1, it says ax squared plus 9x minus 5 equal, and 4 times this polynomial is 4 times 2x squared plus 2, plus 1, sorry. So this is the easy part. This is algebra, elementary algebra. You remove the parentheses, apply distribute the property, it says ax squared plus 4. So basic, in this case, you have this equation. 8x squared plus 9x minus 5 equal 8x squared plus 4. Oh, look at that. This is guy is canceled. And stay alive only 9x minus 5 equal 4. I tried to solve for x. 9x is equal 4 plus 5 is 9. Wow, amazing. I like that answer. And divided by 9, both sides, x is equal 1. Wow, I discovered that yes, exist one famous point in which exist one famous point in which the curve crosses. I promise in few minutes, in few seconds, you see the graph in decimals. Entonces, I discovered one point, que es el point que cross, que es 1, 1, 1, 1, something, no? 1,4, because 4 is the y value of the asymptote. Okay? Entonces it's important when you investigate the horizontal asymptote, you spend some second to meditate if the function cross or no the horizontal asymptote. And you set up the equation and solve the equation. Let me see more clear geometric. You know, one picture is much better than 1,000 words. So now I prepare for you now in decimal again, the example 3. I call example 3 in the decimal, no? Look at that. Decimals. Do you see the decimal, right? This is example 2. We discussed and remember previously. This was the example for the whole, but no whole anymore. Look at that. Wow. Look at that. This is the example 3. Look, I type in the original equation. I determine that we have the horizontal asymptote. Look at the behavior. And behavior. When you approach it to infinity, the red curve approaches but never touch in both directions. This is the idea for the horizontal asymptote. Okay, look. And the negative part, exactly the same. We have a famous point, and not always happen, seldom happen, but it's important when it happens, in which the curve crosses. Okay, 1,4 que we metí. Any question? Any question? No. Super. Everyone follow me, guy? I know that this is hard, a little bit. Wait, I'm waiting. Come on. I'm waiting. You one more time. What? One more time, what? Come on. Activate the microphone. What do you want specifically? Still don't get it. No, I understand. Understand, Meili? Okay. Listen to me. We are discussing theoretical part. I promise in few minutes I integrate everything in 3 specific examples. See, we have time today, we'll have time today. Si no, we continue Friday. Okay? Don't worry, relax. Everything gonna be okay for you. But you be patient. Try to understand the concept. And the concept is, okay, let me summarize so far. The concept is, do you see the whiteboard? Yes or no?
No, Desmond says it.
No,
Desmond.
that's okay. And sometimes happen, I need to restart and share again the screen. Boom. Good?
Yes.
Okay. The topic of the horizontal asymptote is we have P no Q, P of X divided by Q of X, 2 polynomials. So we have two cases, case 1, case 2. I call regular, this is my name, and special. When the degree, regular is when the degree of P is equal degree of Q. Yes, we have add y equal the division, suppose hypothetical example que es 2x squared plus 3x plus 5, x squared minus 6x plus 7. Es obvio que in this case is 2, because it's the division, this number divided by this number que es invisible. Okay? We have a special. A special is when the degree of the Q is bigger than the degree of P. Yes, we have at, well, suppose this example, at y equals 0 always. Suppose this example in which you have 2x squared again, plus 3x plus 5, divided by, but in this case you have in the bottom x cubic minus 6x squared plus 7x plus 7. Degree of this is 2. Degree of this is 3. We have a special case in which the degree of the bottom, is greater than we have. Entonces, the new idea que I discussing is sometimes, not always, we see throughout the example I bring today, sometimes the function crossed the horizontal. Not always happen. It's very, very seldom that the situation happen, but happen. And you need to be aware for that situation. Okay? More clear now? No, don't worry. I suppose that little by little, this is a process. This is a lot of concept, very, very complicated. Suppose that a student get to be accent today. Okay. I promise it's the last asymptote. It's slang asymptote. Slang is different. So far we studied vertical. Vertical look like that. Tap. Horizontal look like that. Tam. And slang is an oblique line. Okay. Entonces, when we have, what is the condition? To have a slang. Suppose this function. Example, I don't remember the number. 9, 10. Suppose. 9. Okay. Example 9. Suppose f of x equal x squared plus 1 divided by x minus 1. Entonces, we are doing exactly the same analysis of the degree. The degree of the polynomial at the top is 2. The degree of the polynomial at the bottom is 1. Entonces, if the degree of P. Okay, remember, I call P top. Always, is the convention. Degree of P is greater than the degree of Q, pero plus 1. Okay, es greater than plus 1. Let me write in English to understand much better. Degree of P is greater than plus 1 is greater than or greater plus 1. Much better my English. Fix it. Greater than plus 1. Greater plus 1 than the degree of denominator. The conclusion is then, yes, we have. We have what? We have slang asymptote. Okay? Entonces, en few words, es super easy. Suppose degree 2, degree 1. Entonces, degree of the top is 1 more. Suppose another example in which degree is 3 and degree is 2. Yes. Degree 3 and degree 1, no, we have no. Because it's greater than 1 more. Okay, 1 unit more. Si the degree of the denominator is 4 and the degree of the top is 5, yes. Si it's 6, no. Okay, the identification of slang asymptote is when the degree of the polynomial in the top is greater than 1. So in this example that I put here, f of x is equal x squared plus 1 divided by x minus 1. Yes, we have. However, this is not totally answer. The answer is where? It's located this line. Because actually, the asymptote is a line, no? It's an oblique line. And the oblique line, you know, in algebra, we have a slope and y-intercept. This is the classical y. This is the slope in a set form of the line. So I need to discover behind this idea, the line. Okay, so I propose you doing long division of the polynomial. Exactly the same we are doing in intermediate algebra. And remember the format for the long division format is something like that. You put here and you put inside the box, you put the polynomial in the top numerator. Numerator is x squared. We have missing the x value, the 0x plus 1. It's important complete the missing guy because it's helpful to keep the order of the long division. It's a little bit complicated. Entonces, you put in the outside the box, you put the divisor. This is the numerator. Okay, this is the numerator. This is denominator, or divisor, dividend, divisor, and the answer is quotient. Okay, this is ready to perform long division. Long division is, okay, what is the expression? Okay, multiply by this, give me x squared. It's obvious it's x, right? You copy x times x squared. And x times -1 and negative x. Do you think it's important? Keep the order. So one column for the x squared, another column for the x power 1, another column for the x power 0, because no x. Now, by subtracting, you change the sign. Change the sign by subtracting. Exactly the same we are doing in elementary school. When you divide, for example, 5 divided by 2 by hand, is 2, 2 times 2 is 4, subtracting is 1. It's the procedure of the long division in arithmetic in algebra. So you cancel out that part, and that part is 1x. Well, you omit the x because the style in algebra when the coefficient of 1 is invisible. Plus, bring down the next guy. How do you know when you stop? Well, you stop when the degree of this polynomial, the remainder, is less than the degree of the divisor. And the degree of the divisor is 1. The degree is 1. In this case, degree is also 1. So you cannot stop. You continue. In this case, it's plus 1. It's plus 1. When you multiply 1 times x, it's x. And when you multiply 1 times negative 1, it's negative 1. By subtracting, you change the sign again one more time. And this is cancelled, and the answer is 2 get the remainder. Okay, entonces, ¿cuál es the conclusion? The fantastic conclusion is this function, que es x squared plus 1, divided by x minus 1, is equivalent, it's the same, expressed in a different way. You write the quotient, is x plus 1. You write the remainder, is 2, divided by divisor. Now this and this is algebraically the same thing. This is equivalent to this. However, you can see more clear now, at least, that this expression represents slant asymptote. So always, guys, we have more complicated example in which you need to perform long division and isolate the line. So basically, my slant asymptote is, look, is y equal x plus 1. You compare y is equal mx plus b, and in this specific example, it's low as 1, because you don't see any number here, and b is 1. And when you are doing the graph of the slant, well, okay, exactly the same we're doing. The y in a set is b, is 1 here, 0.1, and slope is 1, so si slope is 1, remember the definition of the slope is always the ratio between right and wrong. In our specific example, the 1, I suppose it's 1 over 1, so the right is 1, I go up 1 and to the right 1. Yeah, doing the graph of my slant asymptote. And I suppose get the curve, I don't know, approach it, but never touch the slant. I don't know exactly, but I go to decimal to see the idea. Okay, so it's, look, let me show you. Decimals. Switch into decimals. Good. Decimal. Okay, this is the example I call number 3. Well, number 4 is this. Look, number 4 is this function. We have, look, we have two things. We have of course, we have a vertical asymptote, look, but we discovered after the long division process, we discovered the slant asymptote, get this. And the curve, you see, approach it to the asymptote, but never touch. Never touch. I never touch. The only possible touch is the horizontal. In this case, no, never touch. Okay. 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 Do you see a little bit or no? Complicated? Very, eh? I know. Okay. I want to hear opinion, guys. More. Okay. So it's the complicated thing. When something is complicated in mathematics, we need to discover one procedure to go directly to the successfully idea. Okay. Okay, look. So I want to explain step by step what is the guideline to graphic a rational function. Okay, step by step. Step 1, step 2, step 3, step 4, because it look like complicated. Step 1 is they are polynomial with no common factor. Okay, one function is given in the test. Entonces, what mean that? Well, the idea is clear. The idea is you factorization the polynomial. Suppose that after the factorization you have the situation. Suppose two polynomial xx, xx, 3, 2, 2, 5. Negative, 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 negative. You factorization. And you discover, wow, this guy is cancelled. Entonces we manipulate with the rest. It's x minus 3 in the top, over x minus 5 in the bottom, no? And the guy is canceled, is x equal to represent 4. So when you are doing the graph, you temporarily ignore the whole. But when you finish the graph, suppose the graph look like that. Wow. Into 1, 2, like that. And the original. This is the idea behind they are polynomial with no common factor. So you factorization totally, you delete or cancel out the common factor. And another problem, we have no common factor to cancel out. That means that we have no whole. That's it. Okay, step number 2. Step number 2 is determine or find y-intercept. Remember the formula to find the y-intercept is in function notation is evaluate 0. Okay, super, evaluate 0, done. That's it. Number 3, find x-intercept. It's a little bit more complicated because it's f of x equals 0. It's a formula. But in specific, you have p of x divided by q of x. And when the one fraction is equal to 0, it's because this is equivalent to say that p of x is equal to 0. Yeah, I totally ignore the q. Q is not important. See, one fraction is 0, it's because the responsibility to be 0 is only the polynomial in the top. I don't care q, I take p and determine the 0 of p. Okay. Number 4 is find vertical asymptote. And vertical asymptote, remember, we have p of x divided by q of x. After the simplification of the whole, when you have no more whole, you take the polynomial in the bottom, the q, and enforce it to be 0. And the solution for this equation represent the vertical asymptote. Okay? Entonces, this is I don't know why, es the moment que, in my opinion, I do a roughly sketch by hand. This is my all real number, positive infinity, negative infinity. I suppose I plot that point, I plot y-intercept is here on the y-axis. Suppose, hypothetical, here, boom. And x-intercept, suppose they have 2. Plot that. And also, I suppose we have one or 2 vertical asymptote. One vertical asymptote here, and 2 vertical asymptote. Get the solution for this equation. Okay, so I do the rough sketch like that, no? Find horizontal asymptote or slant asymptote. What is the reason I analyze both in one step? Because they are mutually exclusive. So if we have horizontal, we have no slant. And if we have a slant, we have no horizontal. So they are mutually exclusive. Okay? They are like a female and male. You are only one. Okay? See, we have horizontal, we have no slant. See, we have a slant, we have no horizontal. And remember, we are doing the analysis of the degree. When the degree in the top and bottom is the same, yes, we have horizontal. When the degree at the bottom is greater than the degree of the top, yes, we have a special horizontal at y0. And when the degree of the top is bigger than 1, the degree of the bottom is the only possibility we have a slant. And to find this equation for the slant, it's a line, you are doing long division of the polynomial. Okay. Number 6, it's extremely important, is find a symmetry. Symmetry. And symmetry, remember, we are doing that way. Look, you are doing reflection. You are doing reflection. You replace in the original equation, you replace x for negative x. If the answer doesn't change, stay the same, it's because the function is even. And if the function is even, then, wow, it's good because that represents the positive part is exactly the same of the negative part. For example, si you determine 1 point, que es 1,3, hypothetical, acá 1,3. Let me use it in black color. Suppose que I determine in the original function 1 point hypothetically, que es 1,3. 1,3. I know que negative 1 is also 3. It's the same value of the y because it's even. Entonces, suppose in 3 is 3 and 3. This is even. However, when you are doing the reflection, and this is completely opposite sign, this is odd function. Odd function. An odd function is supposed to, again, the point is 1,3. When you change the sign of the x, you change the sign of the y. This is typical odd. This is typical even. And both are special. Even and odd are special because have symmetry. One symmetry respect the y-axis, and here symmetry will respect the origin. Otherwise, when you perform the reflection, and nothing happens, neither, and neither we have no symmetry. Entonces now, unfortunately, with the positive part, the blue part, and the negative part, get the green part, you can do separately, completely independent. There are no relationship. And number 7, que es important, is a plot additional. Additional. And the question always is, the student asks me, Professor, how many points we need to plot? No. Okay, so you plot more points is better. However, the minimum point is, look, let me come back again to the roughly sketch. In the roughly sketch, I determine, remember, in the x-axis, I pay my attention now in the x-axis, on the x-axis. I determine here and here, two x-intercepts. I determine here and here, 2 vertical asymptotes. Look, vertical asymptote. This is vertical asymptote number 1, and this is vertical asymptote number 2. Okay, that would be fantastic. Would be fantastic if you determine, for example, 1 point after the vertical asymptote here. Arbitrary, totally arbitrary. Suppose that this is 3, I take 4 or 5, or 6, and between the vertical asymptote and this point, I suppose that 2, you determine 1 point here, 2.5. 2.5. And in between, it's supposed to be negative 2. Let me use a black color, get much better. Negative 2, so you determine, for example, 0 or 1 or negative 1, arbitrary point here. In between negative 2 and negative 3, get another vertical asymptote. Here is negative 2.5. And after the negative 3 is negative 4. Okay, this is the amount. So basically, the minimum point is 1, 2, 3, 4, and 5 points. In this case, hypothetical, I suppose 2 x-intercept and 2 vertical asymptotes. Because the x-intercept and the vertical asymptote make it a partition in the x-axis. Okay? And we have 4 partition. 1, 2, 3, 4. We have 5. the additional point. One more, because 4 partitions represent 5 intervals. Okay, guys. No more blah, blah, blah. Let's go directly to the example, okay? Prepare for you. In this example, we can see everything together. Everything together. Okay, the example 10, no? Is it 10? It's a 10, right? Example 10. Okay, example 10 is f of x equal 4x divided by x squared minus 4. Okay. Entonces, what is the question? The question is do the graph. It's too long, I know. Find everything. Vertical asymptote, horizontal asymptote, x in the z, y in the z, blah, 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 blah. Everything, everything. Okay, step 1, remember, is a factorization. The factorization is, well, in the top we have monomial. We cannot do anything, but on the bottom, we have a binomial. It's a typical difference of a square. It's xx to 2 plus or minus. Unfortunately, no. We cannot simplification, nothing here. So the conclusion is we have no hole. Okay, this is the most typical example, no hole. Hole is weird. Number 2 is find the y-intercept. To find the y-intercept, you allow the function is 0. And while the function is 0, you can do in the factor 4 or in the original, either way. If 4 times 0, 0 squared minus 4, 4 times 0 is 0, divided by negative 4 is 0. Oh, it's 0. So when the x is 0, y is 0. The point is 0, 0. 0 is the origin. The origin is y-intercept. And when this situation happens, regularly, x-intercept and y-intercept is a coincidence. Because it's a common point, the only point, the origin is the only common point between x-axis and y-axis. Okay, so x-intercept, suppose I don't know, I put f of x equal to 0. And f of x equal to 0 is 4x over x squared minus 4. And remember, I don't care the denominator. You take 4x equals 0 divided by 4, x equals 0 again. So it's 0, 0 is both is x-intercept and y-intercept. In this specific example, in other, no. In other, no. But in this, yes. Okay. Now, number 4 is vertical asymptote. And vertical asymptote is easy. You take the original if you want. Look. You take the original if you want. Or you take the factor 4. I prefer the remember, the formula is cube x equal to 0. And q is x plus 2, x minus 2. I take advantage, que es factor, entonces es equal to 0 es because x is 2 or negative 2. So another way to do that is take the original, x squared minus 4 equal to 0, and you solve in the quadratic equation. Either way, guys. In this case is x squared equal 4, apply square root both sides, x is equal plus or minus, and you get exactly the same answer. Entonces, this is the moment, I don't know why, don't ask me why, I like to do a rough sketch by hand in which I do the graph of the ordinary number line that represent the x-axis. This is infinity, this is negative infinity. And I plot the point, que es 0, 0, que represent x and y in a set. Okay. And plot the two vertical asymptotes to the two positive and two negative. Bam, 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 bam. Dotted line, dotted line, dotted line, dotted line. Okay, let's continue. Number 5 is horizontal or slant. And remember, we are doing the analysis of the degree. Let me copy the function again. The function is 4x divided by x squared minus 4. Degree of the polynomial in the top is 1. Degree of the polynomial in the bottom is 2. When this situation happens, it's because we have horizontal asymptote. Yes, we have horizontal asymptote. No slam. No slam. And this is a special case, is at y equals 0. Okay, so we have here horizontal asymptote. By the way, by coincidence, the famous point 0, 0 is 3 things. Is x intercept, y intercept, and also is the point where the curve crosses the horizontal. Okay, you don't need to determine, because to determine that, you set out the equation, you put 4x over x squared minus 4 equal to 0. It's obvious that we get exactly the same answer of this. It's a coincidence. Not always happen, but in this case happen. Number 6 is a symmetry. Number 6 is a symmetry. The symmetry is f of x, make a reflection, and let's see what happens. So reflection and the original. You replace x for negative x. So it's 4 multiplication by negative x divided by negative x squared plus 4, minus 4. So here is minus 4x divided by, and this square become positive, stay positive, minus 4. And we compare this expression and this expression, is the original. And you see it's exactly the same, but the opposite side, minus here. That is the reason it is odd function. The conclusion is odd function. Since odd function, I take advantage this idea, the symmetry. Because when you compute the positive part, look at that. When you compute the positive part, 1x positive, and you get one value, I suppose, I don't know, it's positive. When you get exactly the same x value, but an opposite sign, you get y negative. This is a typical format for the odd function. Yeah, I take advantage of this. I take advantage of this. And to say number 7 is apply additional point. How many additional points we use? We're using here. For example, I'm using 3. Y3. I'm using 1. Remember, remember we're using 1 point here, 1. We're using 3. Why not? After the 2, que es the asymptote, and 4. Okay, so you evaluate the function. You evaluate the function in 1. This is just algebra, plugging in. The answer is minus 4 over 3, que is negative 1.3 repeated. So the point is the point, 1 comma, negative 1.3 repeated. But I take advantage of the odd property, and I know that negative 1, the answer is exactly the same, but opposite side. Do you think it's important, the symmetry, guy? Because you save time. Suppose it's neither, so it's completely different, the answer, and negative 1 and positive 1. Let me go to another point. I evaluate in 4.3, in 3. And 3 is 4 times 3, 5, 3 squared minus 4, this is 12, this is 9 minus 4, is 5, and decimal is negative 2.5. Negative or positive? It's positive, 2.4. And the point is 3, 2.4, and in negative 3, using the symmetry, is negative. Okay? Put together everything together in decimal. You open now decimals. You open now decimals. You open now decimals. And little by little, you plot the point, you plot the line, the asymptote line, and you plot the additional point, and I suppose you get the answer. Very, very nice. Very, very good. Look at that. Look at that. Look at that. Example. And that's my call example 5. Boom. Look. Okay. Look at that. Look at that. Well, first of all, I put the function. We can use it here y equal 4x over x squared minus 1, but I prefer f. Or g or h, I call here f1. Okay. What is the reason? Because I take advantage for the function notation. I plot the first point, the first famous point, que es 0,0, that's the origin, 0,0. I plot the two vertical asymptotes that we discovered, that was x equal 2, x equal minus 2. Look at that. Look at that. Look at that. Look at that. Vertical asymptote. Vertical asymptote. I plot that. Remember the style is dotted line, black color. I plot the horizontal. Look, horizontal is y0, so it's coincident with the y-axis. And you plug it in. Look, different point. If you compare by hand or using the calculator, right? 1 by 1. 1 comma negative over 4. So this is the point. Look. Look at the point. I plot, for example, let me try to understand. When you plug it in 1, the answer was negative 1.3 repeated. You plot negative 1. It's exactly the same value for the opposite sign. This is a classical behavior of the odd function. Do you see the symmetry? And 4 is 1.3 repeat, but positive. And 4 is negative 1.3 repeat. Okay, and negative 4, sorry. And this is the answer. Right? You plot countable, you open decimal. So you are doing computation in the piece of paper. You open decimals, plot the point, put the line, vertical line, horizontal line, slant, asymptote. Either way, depending on the problem. And you, little by little, you construct your graph of the rational function. It's too long, it's very, very hard. You know, this is only long process. So you understand very well the idea behind this. Okay. Okay. Any question about this problem, guys? Let me move on to the whiteboard. Wait. Do you see whiteboard or not yet?
Not yet.
Not yet. Okay. Entonces I need to restart. Okay. Start sharing. Select the whiteboard. Yes. Now. Okay. You have some question, Ernest? Okay. Entonces you need to no memorize the 7 steps. Number 1, factorization. And cancel out the common factor. Number 2, y in a set. You know the formula. Number 3, x in a set. You know the formula. Vertical asymptote. You know the formula. Horizontal or slant. Bueno, it's the analysis of the degree. Okay, you need to memorize. Number 6, symmetry. Number 7, plot additional point. End the story. Let's move on to another more interesting example. I suppose it's the last one that we are doing today. We continue Wednesday with this topic and we start another new topic. Okay, what number is this example, guy? Number 11 or number 10? 11, no?
It was number 10.
Number 10, okay. Number 10. So this is the function g of x is equal to x squared minus 3x minus 5 divided by x squared plus 1.
No,
This
it's 11.
It's 11. Okay, it's not important. Okay, this is the function that's given. Entonces, the same, we apply the 7th step to do the graph of the rational function, no? Remember, the first step is always factorization. Factorization the polynomial, and in this case, trinomial, no? So you factorization 2x squared minus 3x minus 5, no? So remember, this is a special trinomial. You multiply this number and this number, the answer is 10. I don't care this sign. and the combination is 5 and 2, I suppose, no? It's obvious, no? If 5 times 2 is 10, if 5 minus 2 is 3. And you separate like that, 2x squared minus 5x plus 2x minus 5. And you apply factorization by grouping. Grouping here, grouping here. And the factorization by grouping in the first couple is x. 2x minus 5. And the common factor here, we have no common factor. Well, yeah, we have que 1, 2x minus 5. Entonces, 2x minus 5. Open las paréntesis, x. Okay, the factor form of this function is, in the top, is paréntesis 2x minus 5, x plus 1. And the bottom, and the bottom is binomial. But remember, when you have x squared plus 1, when you have the sum, okay. Let me recall intermediate algebra, because it's important, no? Okay, in binomial, we have this situation. Look, a squared minus b squared is the famous difference of a square. Okay, we are doing every day, and the factorization is something like that. However, when you have a sum of a square, it's prime expression. It's prime expression. It's impossible factorization to live like that. Impossible factorization. Okay, super. This is the factor form of my problem. Again, we can see that we have no common factor to cancel out. No. Therefore, we have no hole. In this problem, we have no hole. Okay. I like that. No hole. Okay. Now, after that, y in a set. Y in a set. Y in a set is the function evaluating 0. In my opinion, it's easy. Plugging in 0, no in the factor force, in the original. So if you replace x for 0, this is gone, and the top stay -5, and the bottom stay +1. Therefore, -5 divided by +1 is -5, and the point is the point 0, -5, because x, I suppose, is 0, and y and -5. This is my famous y in a set. And my x in a set is when the function is equal to 0. And remember, you take always the top part equal to 0. So basically, I take advantage. Get this polynomial or this trinomial is factory already. And I take this equal to 0. Entonces, I separate in two linear equations, 2x minus 5 equal to 0, or x plus 1 equal to 0. It's obvious that the first solution is I move 5 to the other side, divided by 2 is 5 over 2. Okay, in decimal if you want, because it's good when you are doing the plot graphically. It's much better decimal, no fraction. It's 2.5. 2.5. And here -1. What is the conclusion? We have two x in a set. We have only one y in a set, que es 0.5, -5. However, we have two, it is 2.5, 0, and -1, 0. We have two x in a set. Okay, entonces good, because at least we have 3 points in my problem. Okay, what is the next step? Well, the next step is find the vertical asymptote. Vertical asymptote. And vertical asymptote is easy because you take the polynomial in the bottom. Vertical asymptote. You take the polynomial in the bottom, que es q. In our specific example, q is x squared plus 1, and you force it to be equal to 0. Okay, but professor, you say that this binomial is impossible factorization. I understand. But suppose that you don't see very well, and you try to solve this quadratic equation, no? Actually, it's quadratic equation. Entonces, x squared equal -1. You apply square root both sides. X alone is equal plus or minus I. Then, when in algebra, this is important statement I want to explain now. Listen to me. When in algebra, you try to find something that you don't know. And when you manipulate the algebra and you get imaginary number or complex number, the interpretation is that this thing that you try to find does not exist. O sea, I set up the corresponding equation for the vertical asymptote. But when I manipulate the algebra, the answer was imaginary. Si es imaginary, it's because this function have no verticals. Okay? No. Have no verticals. Okay? Unfortunately, verticals is super useful to describe the graphic, but well, we have no, because the solution of the polynomial at the bottom was imaginary. Okay. Let's move on to the horizontal asymptote, no? It's the next step. Horizontal or slant? I have no idea. We're gonna like both simultaneously. Horizontal or slant. Entonces, horizontal or slant. Remember, the analysis is the analysis of the degree. Let me copy the original function g of x is equal. What's going on? Okay, here. Is equal 2x squared minus 3x minus 5 divided by x squared plus 1. Okay, super. What do you think? We have or we have no horizontal? Or slant?
We have.
We have. How do you know?
Because d equal to and d in the bottom is 2.
Exactly. This is the idea. At what value? Y equal what?
Y equal
1.
2 divided by 2.
2 divided by 2.
Oh,
2 divided by 1.
but
Yes? Okay, you divide the leading coefficients. What are the leading coefficients in the top? 2.
yeah, equal to.
Entonces, 2 over 1 is 2. So we discover, yes, we have a y equal to. Complementary to this idea, I need to investigate if the function cross or no, si the function cross or no, look, the function that is cross or no, 2, que es the horizontal. I need to investigate, mandatory guys, mandatory always. You apply cross multiplication, to x squared minus 3x minus 5 is equal to 2 times x squared plus 1. You have this equation, apply this derivative property to x squared plus 2. Now, I try to solve this equation. 2x squared minus 3x minus 5 equal to x squared plus 2. You see that that part is the same. It cancels out. Minus 3x minus 5 equal positive 2 is the idea, no? And then you move minus 3x is equal to plus 5 is 7, no? Divided by negative 3. The answer is x equal negative 3, sorry, minus 7 over 3. Entonces, I determine que yes, the function crosses the horizontal asymptote at the point negative 7 over 3, comma 2, no? Because the y value is 2, comma 2. And decimal approximation is negative 2.3. Negative 2.3 repeated, no? This is the famous point in which the curve never not touch, cross the horizontals. Okay. The next step is symmetry. Symmetry. Es obvio que no symmetry, it's neither. Let me analyze quickly because it's super easy. Suppose 2x squared minus 3x minus 5 divided by x squared plus 1. When you replace x for negative x, que es the test of symmetry, and the function notation, you replace this for this. And we compare what happened. It's obvious que the exponent 2 stay the same. And it's obvious que the constant stay the same. The only guy that do not stay the same is this. See, at least one change is neither. Because remember, it's same. And odd is opposite. Otherwise, it's the most common, the most popular is neither. That means that we need to compute separately the negative part and the positive part, unfortunately. But it's neither. Entonces, quickly, we compute this, pero I don't want to waste the time. I'm using decimals directly. Look at that. Look at that. Decimals, I switch into decimals, que es the last part. Switching. Okay. Do you see decimal, right?
Yeah.
Okay. Okay, this is example 6. Example 6 is, look, that function, 2x squared minus 3x minus 5 over x squared plus 1. We are doing the graph in blue color. Look at that, blue color. Remember, we discovered that we have no vertical, asymptote, no. We have one horizontal at y equal to, get this, look. And we discover also that the curve crossed in this point. They put in black color. Okay, negative 2.3, comma 2. Look, make it zoom. And the rest is additional point. I select totally arbitrary, 2.5, 0. And oh, sorry, the most important point, the green color, is the y-intercept, y-intercept is 0.5, and the x-intercept is 2.5, 0, make it zoom, and negative 1.0. This and this are x-intercept. This is y-intercept. And the additional que I'm using is only 3. 1, negative 3, 5, 1.15. Where come from? Well, when you evaluate using the calculator. And negative 3, 2.2. Okay? Okay, guys. Enough for today. We continue working in this topic next time. Another little bit complicated example. And also, we start new topic is very similar to this. It's related somehow with this. Okay, so I come back to the original screen. Guys, let's wait only 1 minute. 1 minute. I want to drink some water, no? And stay with you to solving. Entonces no mandatory, guys. The student que want to leave, you can leave. Even I stop recording